The intent of the family of international codes is to establish reasonable levels of health, safety, property protection, and public welfare. In the minds of the construction industry, when these words are mentioned, they instantly think about fire-rated construction, smoke detectors, and sprinkler systems. Now, there's no question that these are life safety measures, and they're provisions that you're going to find within the International Building Code and the International Residential Code. The International Plumbing Code does mention what to do when plumbing penetrates the fire-rated construction, but its main focus is on making sure the water is safe by removing the potential for any contaminants or diseases from entering our homes and buildings. It creates a confidence in the water we take from the tap to drink. The same can be said when we talk about the International Mechanical Code. It provides provisions for ductwork penetrating fire-rated construction, but the main focus is on heating and ventilating the structure and the required sensors and alarms for the various chemicals that could be emitted into the air. The conventional thought process is that of health, safety, and welfare codes regulate for events that could potentially happen, such as fires, failures of structural integrities, and contaminated drinking water. The International Energy Conservation Code, or IECC, is not often classified as a traditional health, safety, and welfare code, but nothing could be further from the truth. The IECC regulate events that are already occurring now, such as moisture management, indoor air quality, fire safety, extreme weather events, shelter in place, and the resiliency of the structures. Let's take a look at the first topic mentioned, moisture management. The IECC works with the IBC and the IRC to help manage moisture within the structure. We do not want to trap moisture within the assembly, so we transfer the moisture in controlled settings by utilizing building science. A typical 4x8 sheet of unpainted gypsum board during a heating year can produce 1/3 of a quart of water through vapor diffusion. Now, that same 4x8 sheet of unpainted gypsum board with a 1 square inch hole in it can produce 30 quarts of water over that same heating year. This is where the synergy between the vapor retarder requirements on the warm side of the exterior wall and the thermal envelope insulation and air barriers work together to help mitigate the accumulation of moisture in these assemblies. When discussing moisture management, we need to address the concern over condensation. The IECC understands the building science behind condensation, and there are requirements for slab edge insulation. When you have a cold slab installed within 24 inches of grade for commercial projects and 12 inches of grade for residential projects, you are required to install slab edge insulation. Condensation can develop when you have a cold slab and a heated structure above. Think about what happens to your glass of lemonade when it contains ice. The heat surrounding the coldness in the glass develops condensation on your glass. It's the same concept that happens in the building. Trapped moisture that remains within a wall or an assembly at some point will cause that wall or an assembly to fail prematurely. But before that happens, it's likely to expose the occupants to health hazards such as mold, viruses, bacteria, pests, and pathogens associated with sick building syndrome. The next topic I would like to discuss is indoor air quality. Air is an excellent transfer mechanism for all sorts of things, including water vapor, atmospheric pollutants such as smog, exhaust emissions, pollen, and smoke from either structure fires or wildfires, which is something that has been really prevalent as of late. The IECC helps to mitigate these with the requirements for air barriers and air sealing. More specifically, the types of materials that are utilized and the location where these barriers are going to be installed. The intent is to control how and where the air moves, infiltrates, and circulates inside the building. Have you ever removed old bat insulation and noticed the massive discoloration on it? The discoloration you see isn't from mold or mildew. It's due to the contaminants that have infiltrated the structure where there wasn't a properly installed air barrier system. The insulation trapped or partially filtered those contaminants. Now, the IECC requires that ducts, air handlers, and filter boxes are sealed. The residential provisions even require that the duct systems be tested for the amount of air leakage that occurs. If you have air leakage into a structure through unintended openings, you no longer control the movement of the air. This can affect the heating and cooling of the structure and the overall air quality. If the air leaks into a vented crawl space, it becomes exposed to various contaminants, and those contaminants can infiltrate into the structure for the occupants to breathe. The IECC requires that if outside combustion air is brought in for fuel-fired appliances, you must either locate the room outside the thermal envelope or you need to thermally isolate the room. Specifically in residential buildings, when the required outside air was brought in through ductwork, it often made the floors above the mechanical equipment cold. The occupants would then investigate and realize that it was the ductwork that was bringing in the cold air, and often would place items such as towels in the ductwork to block that cold air, or they apply plastic over the openings, and much to the dismay of the inspectors. Now, either situation constricted the cold air from entering the structure, but also restricted the combustion air that the mechanical equipments required to perform safely. The lack of a combustion air can cause carbon monoxide issues, soot, and issues with a continuous flame. The third topic is fire safety. The IECC requirements for tight construction, including air barriers and air sealing, in cooperation with rated assemblies, allows for the containment of smoke and limiting the spread of fires from nearby buildings. The continuous air barrier requirements for both commercial and residential structures require that the joints, seams, and breaks are all sealed. This limits how the air can enter a building, which assists with reducing or mitigating smoke damage from neighboring structures that may be burning, and by sealing up all the cracks and holes in the assemblies that separate conditioned space from unconditioned space, helps to mitigate the spread of fire and smoke within the structure or to nearby structures. The fourth topic I'd like to discuss is the concept of shelter in place. Having a good thermal envelope, which is required by the IECC, assists the occupants to be able to shelter in place when confronted with extreme weather conditions, or with our recent crisis, the COVID-19 pandemic. Now, we're very fortunate that this pandemic arrived in between our typical severe weather seasons. Many of us were under a stay-at-home order issued by our various state governments in an attempt to keep us safe by enforcing social distancing. Now, most of us still attempted to work from home, or we tried to catch up on some shows that we had been missing out on, or we had children trying to perform schoolwork from home under these trying conditions. I suspect most of us are more acutely aware of whether our house was comfortable and was able to maintain the desired temperature without stressing the mechanical equipment. You also probably noticed how much water ran down the drain while you were waiting for that hot water to roll out of the faucet so that everyone could wash their hands. What if we were experiencing extreme weather conditions and we had to deal with a power outage because of a downed tree due to wind or snow, or because the grid was overloaded from the use of all the air conditioners in the summer? If the structure has a good thermal envelope, including air barriers, the occupants will be able to stay in the structure longer because the structure is able to maintain a temperature that works for the occupants. This may allow them to shelter in place until the power is actually restored. This is going to assist your community with not overburdening its limited resources. For an example, the evacuation location or shelter will not be overcrowded, which is going to be a benefit for multiple reasons. especially with addressing the social distancing requirements that we are under for the COVID-19 pandemic. And probably the most relevant benefit is less chance of being exposed to viruses or other pathogens or contagions during this time. Now, less people will be utilizing the roads, mitigating potential traffic jams or accidents, which allow for repair crews and first responders to utilize them as better to serve their respective communities. The final topic I would like to mention is the concept of resiliency. When homes and buildings are built to the newer building codes, including the IECC, these codes assist with mitigating some of the damage that natural disasters can cause to a structure. This is something that has been recognized by our federal government, by FEMA, and by insurance companies. When disasters occur in a community, everyone is affected by it, and there is a lot of money and resources being spent. If a safety assessment professional, something that Colorado's had to use on many occasions in many communities in the past, does not have to inspect a development or a neighborhood, it allows them to process property damage faster. While here in Colorado, we are extremely fortunate that the Colorado chapter of ICC holds trainings to certify and continue the education of our local inspectors, plans examiners, and permit technicians to be qualified to perform these assessments. There are many locations that are not as fortunate, and they have to rely on outside entities to assist with these assessments. Typically, they're donating their own time to do it, but there are still many things to keep in mind. They are required to have shelter, something that could be in a really high demand with the local residents removed from their own homes. They're going to be required to eat, right? And that can be a concern for a community with limited supplies and limited transportation to bring in those supplies. So even with all of this, it still takes time and money from the affected communities to try to get back to normal. If you have structures that are more resilient during these times, the amount of money and time saved by these communities can be significant. The opportunity for local residents to have the ability to stay in their own home instead of a shelter or being relocated is absolutely priceless. As you can see, the utilized term of life safety encompasses many aspects of the construction process for safeguards for public health, safety, and welfare, which does include the International Energy Conservation Code.